At this time, we are in the middle of course called as Databricks Certified Associate Developer for Apache Spark 3.0. In this sectional module, we will primarily focus on aggregating the rows as part of Spark data frame. When it comes to aggregating rows as part of Spark data frame, we typically perform total aggregations as well as grouped aggregations. For example, a count on a data frame is nothing but a total aggregation, and also sum of a particular column which belongs to a particular data frame is also example for total aggregation. When it comes to grouped aggregations, we typically use groupBy. We group by a particular key. Once we group by a particular key, we perform aggregations on certain fields. That is called as grouped aggregations or by key aggregations. Examples are nothing but the salary expense for each department within an organization, where department will be the key. For each department, using salary expense of each employee, we should be able to aggregate to department level. In the similar manner, we would like to understand how an e-commerce platform is performing per category. Generating revenue per category is also another example for grouped aggregation. Let's go through all the important APIs that are available as part of Spark to perform both total aggregations as well as grouped or by key aggregations. As part of this sectional module, we are going through the details related to performing aggregations using Spark data frames. In this lecture, let's validate datasets which will be used for aggregations using Spark. We'll be using retail_db_json dataset. As part of the DBFS, we have the files in this location. You should be able to run it and you should be able to see the output. If you are using some other cluster, if the data is there as part of HDFS, you might have to use HDFS DFS ls command. Especially if you are using our labs, you should be able to use this location as well. As part of /public/retail_db_json in our lab, we have the dataset. You should be able to use HDFS DFS-ls and you should be able to review the location to see if it contains folders and files or not. When it comes to DBFS under my account, you can see that there are several folders and files. In this case, we are more interested in the folders such as categories, customers, departments, order items, orders, products. So these are the ones which actually have JSON files with some realistic data. We will be using this to actually take care of aggregations as part of this sectional module. Let's validate by picking up a couple of datasets and then we'll actually move on into the tasks. In this case, when it comes to the files in these folders, they are of type JSON. As the files are of type JSON, we should be able to leverage spark.read.json to actually read the data which is in JSON format in this location into the data frame. Now let me run this. A data frame by name orders is created. We should be able to preview the data by using orders.show. You can also expand this and you should be able to see the column names along with the data types. However, let's run this to actually preview the data. You can see the data here. You can also print the schema using print schema. You can see the schema here. So far we have validated the location to confirm the location content folders as well as files. Then we have used spark.read.json by passing the orders location to read the files in this location into a data frame by name orders. To make sure we are really comfortable with this process, let's make sure we create another data frame by name order items. When it comes to order items, the location is nothing but public retail db_json order items. This will take care of creating a data frame by name order_items. You can see that the data frame is created. You should be able to preview the data and also you should be able to preview the schema by using a print schema. When it comes to order items, it contains 6 fields, whereas the orders contain 4 fields. That being said, don't worry too much if you do not get completely about reading the data from the files into the data frames at this time. We'll be covering those details as part of dedicated sections related to reading the data from files into the data frame. Let's make sure that we are able to create data frames by using these code snippets. As long as we are able to create these data frames, we should be able to use these data frames to explore aggregations using Spark. As we have successfully validated datasets for aggregations, let's get into the tasks related to performing aggregations using appropriate APIs that are available in Spark. As part of this lecture, let's go through some of the common Spark aggregate functions which we use on regular basis. They are nothing but count, sum, min, max, and average. All these functions are available under module pyspark.sql.functions. Spark also provides quite a few other aggregate functions including statistical functions such as standard dev. Now let's understand how we typically use these functions, if at all we have to use as per the requirements. To explore, first I am creating a data frame by name orders using JSON dataset which is there as part of this location. Now you can see that orders is created. It is of type data frame. If you want to use any statistical function, first you need to figure out the function name. Then you should be able to import like this. As it is a part of pyspark.sql.functions, we should be able to use this piece of code to import any function. In this case, I am importing count. Now you should be able to see the help if you want to explore details about this function. Now you can see the help. Count takes column name as argument. You can pass column name as string or column object. You can also pass star with respect to count. When it comes to the documentation, it doesn't provide all the information, but it actually supports column name as string or column object, or even you can actually pass star. It will work as expected. You can see that I'm actually saying orders.select of count of star dot show. Now if I run this, I'm able to get the count. We can also perform aggregate functions using groupBy. As part of ag, we should be able to leverage aggregate functions such as count like this. Even this count is from pyspark.sql.functions, whatever we have imported here. In this case, I'm actually using as part of ag. Now we are actually trying to get the count by order status. When it comes to orders, it have a column called as order status. There are 9 statuses. We are trying to get the count for each status. This is another example of performing aggregation. This is called as total aggregation. This is called as grouped or by key aggregation. In either of the cases, we should be able to use aggregate functions such as count, sum, min, max, average, etc. That being said, now let's go through a few more examples to understand all the nuances related to common Spark aggregate functions which we use on regular basis. As part of this lecture, let's go through the details related to performing total aggregations on a Spark data frame. First, let's create a data frame by name order_items. You can see that the data frame is created. You should be able to review the details of this data frame by using attribute called as dtypes. You can see here, it has 6 columns. The columns are nothing but order item ID, product price, quantity, then subtotal. You can also review the data types here. Now, when it comes to the first task, it says get revenue using order item subtotal for a given order item order ID. You can actually take 2 as examples. So we have to come up with a logic where data frame is filtered based on order item order ID equal to 2. It will actually create a new data frame. Using that new data frame, we should be able to come up with required logic to get the revenue using order item subtotal. We should be able to pass order item subtotal to sum, and we should be able to get the revenue for the given order ID. Let's go to the details so that you understand what I'm talking about here. In this case, to filter the data in a data frame, you should be able to use filter. When it comes to the condition, you can actually pass the condition either using SQL style or non-SQL style. Also, in place of filter, you should be able to use where. Filter and where are aliases to each other. You can use either of them. In this case, I'll be using a filter with SQL style syntax. Then I'll actually walk you through the details about how to get the revenue using the new data frame that is being created using filter. Now I can say order_items dot filter. I should be able to say order_item_order ID equal to 2. It will take care of creating a new data frame for us. You can see here, as this is just a narrow transformation, it will not trigger the execution immediately. To actually preview the results to see what all data the new data frame that is being created here have, you should be able to use show and you should be able to preview the data. Now let me use show. Let me preview the data. You can see the data in this data frame. It contains only 3 records. Now using order item subtotal, we should be able to compute the revenue. For that, I should be able to say order items dot filter order item order ID equal to 2. Then select. Then sum of order_item_subtotal. It will again create a new data frame. It will not trigger the execution immediately. We have to use actions such as show to actually trigger the execution. So let me say show, which will actually trigger the execution. However, sum is not imported yet in this session, and hence I need to add a new cell here. Then I have to say from pyspark.sql.functions import sum. It will take care of importing the sum. Now, if you wanted to see the help on sum, you should be able to say help, then pass sum to it. You can see the help on sum. You can see that sum also take one argument. The argument is nothing but column name. The column name can be passed as string or column object. In this case, I have passed the column name as string, not as column object. If you want to pass as column object, you can pass as column object as well. We typically pass column objects in case if you want to manipulate the data in the columns before performing the sum. In that scenario, we might use column object. Otherwise, for sum, we typically pass columns as strings only. It is not only with the sum, but also with all the other aggregate functions. We typically pass the column names as strings the way it is demonstrated here. Now let me run this. You can see the output. So the order revenue for order D2 is nothing but $579.98. That being said, in this case, if you look at the column name, it is a bit cryptic. We might want to provide alias. If you wanted to provide alias, we should be able to provide alias like this. On top of sum, we should be able to invoke alias because sum returns column type object. Column type objects expose a function called as alias. We should be able to give the name of our choice as part of the alias. In this case, let's say order underscore revenue. Let's run it. Now you can see that the column name with respect to the data frame that is being created is changed to order underscore revenue. You can see the revenue as well here. Now let's perform another task. This time we'll try to get number of items, total quantity as well as revenue for a given order item already. We can leverage this piece of code and improvise it further to get additional information. Already this piece of code have the logic to take care of this one. We just have to add required logic to take care of these two. I have already copied. Let me paste. Let me make sure this is formatted properly so that the code is a little bit readable. Now let me improvise on this to take care of these two items as well. In this case, the first function is supposed to be count. We should be able to pass order underscore item underscore quantity. We can also use star with respect to count. It need not be a specific column when it comes to count. That being said, we should be able to say dot alias. Then we should be able to provide the alias to this derived logic. Let me say total items, or let me say item count. I have given the name as order item count. Now let's use sum on top of order underscore item underscore quantity. Let's use alias once again and provide the alias as order quantity. Now we should be able to run it and we should be able to see the results. However, it is failing because count is not imported. We need to make sure count is imported. You can see the error here. It is saying name count is not defined. Now let's pick this piece of code. I need to make sure that I change sum to count. Sum is already imported and hence we don't need to import sum again. Now count is also imported. Now let me run this. We should be able to see not only the revenue but also total quantity as well as number of items in the order. Now let me improvise on this to take care of these two items as well. In this case, the first function is supposed to be count. We should be able to pass order underscore item underscore quantity. We can also use star with respect to count. It need not be a specific column when it comes to count. That being said, we should be able to say dot alias. Then we should be able to provide the alias to this derived logic. Let me say total items, or let me say item count. I have given the name as order item count. Now let's use sum on top of order underscore item underscore quantity. Let's use alias once again and provide the alias as order quantity. Now we should be able to run it and we should be able to see the results. However, it is failing because count is not imported. We need to make sure count is imported. You can see the error here. It is saying name count is not defined. Now let's pick this piece of code. I need to make sure that I change sum to count. Sum is already imported and hence we don't need to import sum again. Now count is also imported. Now let me run this. We should be able to see not only the revenue but also total quantity as well as number of items in the order. You can see that order item count is 3, the quantity is 7, the revenue is nothing but $579.98. This is the information related to order item already 2. You can also compare these details with the data that is there as part of the data frame which is created because of the filter. Let me say show here on top of order items dot filter. Let's review the data. You can see that it have 3 items. That's why we are seeing 3 here. When it comes to order quantity, we have 1 for one record, 5 for another record, and 1 for the third record. If you add these 3, it is 7. That's why you are seeing 7 here. If you add these 3 values that are part of order item subtotal, then you will be getting $579.98. This is how you should be able to perform total aggregations on a Spark data frame using functions such as count, sum, etc. You can also leverage min, max, average depending upon your requirements. That being said, make sure you are really comfortable about understanding the requirement and also come up with the logic using appropriate functions. First, you need to make sure whether it is a total aggregation or by key aggregation. If at all the requirements sound like aggregation style, then you have to take care of exploring required APIs and use those APIs to actually get the desired outcome. As part of this lecture, let's go to the details related to getting count of a Spark data frame. Once the data frame is created, on top of that data frame, we can actually use count function like this to get the count. In this case, this is nothing but action. It will trigger execution immediately. Also, we should be able to import count from pyspark.sql.functions. Once we import it, we should be able to use it as part of select to get the count from a Spark data frame. Let's go to the details, and we'll also understand the differences between using this approach versus this approach. Now, let me run this. A data frame by name order_items is created for JSON data that is there as part of this location. Now I would like to see number of records in this data frame. I should be able to use count function on top of data frame directly. You can see that it have returned the number of records in the data frame immediately. If the data size is bigger, it might take some time, but in this case my data size is not very big and hence it is returned in few seconds. That being said, when it comes to the type of this, it is nothing but int. If the number is too big, then it can be big int or long, but typically you will see numeric type when it comes to type of the object that is being created when we perform action called as count on top of data frame. Also keep in mind that if you use count function directly on top of data frame, it will trigger the execution immediately. That is why it is called as action. Now we also have count function as part of pyspark.sql.functions. Count is imported. If you run this, it will actually create a data frame. You can see that a data frame is created. Also, it didn't trigger the execution immediately. So in this case, count is nothing but white transformation which is being used as part of select. Once we use some action on top of it, then you will actually trigger the execution of this data frame that is created by this white transformation. One of the actions which we can use, especially when we leverage count to get the count, is show. If you use show on top of the data frame that is being created here, you should be able to see the results in it. Let's run it. You can see the output here. It have 172,198 records. Only when I use show here, it have triggered the execution. So this is how you should be able to get the count from a given data frame. Sometimes the requirements might say get count of certain type of orders. In that scenario, you might have to use filter first. You can filter the data depending upon the requirement by passing the appropriate condition. Once the data is filtered, it will create a new data frame. Either you can use count on top of that new data frame as an action to get the count, or you should be able to use select like this to get the count. Typically, in most of the scenarios, to get the count, we perform the action, then transformation like this. Keep in mind that we have two different ways to get the count. One is by performing the action on top of the data frame. Second one is by using count function that is there as part of this. This count function can be leveraged as part of functions such as select on top of the data frame. This will actually create a new data frame. To actually see the results, you have to trigger actions such as show. Only then you should be able to see the results. Make sure you understand these subtle differences. You might face few questions around this when it comes to the certification exam. If at all they ask any question around count, it will be pretty straightforward to answer. So make sure you go through these details and be prepared. When it comes to aggregations, so far we have gone through the details related to total aggregations. In this lecture, let's get an overview of groupBy to perform grouped aggregations or by key aggregations on Spark data frame. First, let's create a data frame by name order_items. Now let's go to the help. When it comes to groupBy, it actually takes varying arguments. You can see here. In place of calls, either you can pass a list or one string or many strings or one column or many columns. These are the arguments which we can pass with respect to groupBy. You will understand what actually happens when we use groupBy when I actually demonstrate using relevant examples. Also, you can actually go to the examples here and understand how groupBy can be used. You can also go to the output and understand what is going on internally. That being said, I will actually go to the details about using groupBy in this manner. I will explain the details as part of this lecture. In the subsequent lectures, we will actually go to the groupBy from the perspective of performing grouped aggregations or by key aggregations. When you actually use groupBy like this without any columns, it will try to perform this aggregate function on top of all numeric columns. Let's take an example so that you understand what I'm talking about here. Before going through the actual example, let's get the count on order items. We have 172,198 records. Let's also preview the data. When it comes to order items, it has 6 fields: order item ID, order ID, product price, quantity, and subtotal. When it comes to ID, order ID, product ID, and quantity, they are of type integer. When it comes to product price and subtotal, they are of type float or double. Keep in mind that all these are of type numeric only. As long as you have columns which are of type numeric, then whatever function you use after groupBy, it will be applied on all the columns. In this case, as all the columns are of type numeric, the min will be applied on all these columns and you will be getting a minimum of all the values related to these columns. Let's run this and let's review the output. You can see the output here. When it comes to order item ID, the minimum is 1. When it comes to order item order ID, the minimum is 1, so on and so forth. Now we can also create another data frame by name orders. When it comes to orders, it have couple of non-numeric type fields. Let me first use D types on this so that we can review the data types of all the columns. You can see that orders have 4 fields: customer ID, date, ID, and status. Customer ID and ID are of type BigInt. Date and status are of type string. Now let's understand the behavior when we use aggregate function on top of groupBy without passing any columns. I have said orders.groupBy without any columns, then .min, then .row. You can see that we are only getting minimum of order customer ID and order ID. It is because they are of numeric type. When it comes to order date and order status, they are not numeric type. That's why there are no details related to those 2 fields. Now you can also actually create object like this. In this case, I have used groupBy without passing any arguments. The object name is nothing but order items grouped. Let's check the type of order items grouped here. Let me first copy this. Let me say type. Let me paste order items grouped. You can see it is of type grouped data. Now when it comes to objects like order items grouped, which are of type grouped data, it actually exposes functions such as count, sum, etc. We should be able to use those and we should be able to perform aggregations. That's what we have done here. You can also pass columns to groupBy. Even then it will actually create grouped data object only. Whatever functions with respect to aggregations we are seeing here will be available even when we actually pass arguments to groupBy. Now let's go back to the help related to groupBy. If you go to the examples in groupBy, we have already gone through this. There are 3 other examples. If you keenly observe these 3 examples, these 3 uses 3 different styles of using groupBy. We will go through all these 3 different styles and understand how to take care of performing grouped aggregations or by key aggregations using Spark based APIs. In this case, it is using ag on top of grouped data frame. In this case, it is using aggregate function directly on top of grouped data frame. This one also related to using the functions directly. However, when it comes to groupBy, we are actually passing the columns as list. That is the only difference between this and this. Now, as part of the subsequent lectures, let's go through some of the examples so that we are comfortable with the different styles of using groupBy along with aggregate functions. As part of this lecture, let's go to the details related to performing grouped aggregations using direct functions on a Spark data frame. In this case, I am referring to grouped data frame. As part of the previous lecture, we have seen that once we use groupBy, it will actually create a data frame of type grouped data. Once you have data frame of type grouped data, you should be able to invoke aggregate functions directly on top of it. When I say aggregate functions, I am talking about sum, min, max, etc. We should be able to invoke them directly. Also, we should be able to use a special function called as ag, and as part of ag, we should be able to pass functions such as sum, min, max, etc. to perform the grouped aggregations. In this lecture, we will be talking about using direct functions such as sum, min, max, etc. on top of grouped data frame. First, let's create the data frame. In this case, I have created the data frame by name order_items. Now, in this case, I'm actually creating a new object by name order items grouped. If you check the type of order items grouped, it is nothing but pyspark.sql.group.grouped data. It actually exposes functions such as ag as well as direct functions such as sum, min, max, etc. You can actually add a new cell, copy the name of the data frame, then say dot and hit a tab. You can actually see all the aggregate functions in this. That being said, we should be able to use all these aggregate functions on this grouped data frame and perform aggregations. Let's see a few examples so that you understand what I'm talking about. Also, you need to understand some of the nuances when you use these functions. This is the simplest example. In this case, I'm actually using order items grouped and performing count without passing any columns to it. As part of the groupBy, you can see we have order item order ID. As part of the count, you can see that I'm not passing any column names. Let's understand the behavior by running this. Now you should be able to see the output. You can see that we are actually seeing the count. When we use count, whether you perform count on one column or all the columns, it will return the same value, and hence you are seeing only one column, which is nothing but count, and you can actually see the count here. In case if you would like to rename this field, you should be able to use with column renamed, and then you should be able to rename count to whatever you want to. Let me copy this. Let me paste here. Now I should be able to say with column renamed. Let's rename the count to order count. Now if you run it, you should be able to see a different name with respect to the order count column. It is nothing but order underscore count. Keep in mind that we are only getting one column here. It is because when it comes to count, once you group the data by a specific column, irrespective of the column you use to get the count, it will return the same. It's very important for you to understand. Even if you do not understand, don't worry. Once we see the next example, you will understand what I meant here. Now if I scroll down and if I run it here, if you review the output, you will see sum of all numeric fields. You can see here when it comes to order items, it has 6 fields. All the 6 fields are of type numeric. You should be able to validate by saying order underscore items, then D types. You can see that order items contain 6 fields. Here are the 6 fields. The names of the fields are nothing but order item ID, product ID, price, quantity, and subtotal. When it comes to order item ID, product ID, and quantity, they are of type bigint. You can see here. When it comes to product price and subtotal, they are of type double. Now all of these are nothing but numeric types. As all of these are numeric types, you can actually see the sum for each and every field where data is grouped by order item order ID. It includes order item order ID as well. You can see here. It actually returned 7 columns. The first one is nothing but order item order ID, then sum of order item ID, then sum of order item order ID, then product ID, product price, quantity, subtotal, which means it have returned 7 columns in this case. Now let's read data from orders into a data frame called as orders. Orders contains 4 fields. We should be able to use either print schema or D types to actually review the schema. If you look at the types of the fields, when it comes to date and status, they are of type string. When it comes to customer ID and ID, they are of type long. These 2 are numeric type. These 2 are non-numeric type. If you use sum on top of orders after grouping by order date, in this case, you will be seeing sum only for order customer ID and order ID. Let's run this and then let's review the output. You see here, it is only returning 3 fields. The first one is nothing but key, which is nothing but order date on which we are trying to group the data. The second one is nothing but sum of order customer ID. Third one is nothing but sum of order ID. As these 2 are numeric fields, we are actually seeing sum for these 2 fields only. So you have to be a little bit careful when it comes to using this approach to actually perform the aggregations. Now let's say I would like to get sum of order item quantity and order item subtotal grouping by order item order ID. I would like to use the direct functions on top of groupBy. To actually demonstrate, first let me redefine order items grouped by just selecting the fields which I am interested in. They are nothing but order item order ID, order item quantity, order item subtotal. Then I'm actually grouping by order item order ID. Now order items grouped is grouped data frame. We should be able to check the help on sum function that is there on top of grouped data frame to understand how we can leverage it. If you look at the syntax of sum, it takes varying arguments. When it comes to calls, they are supposed to be of type string. If you review the details related to parameters here, it says calls is supposed to be of type string, which means whatever call names we are going to pass to sum, they are all supposed to be of type string. Also, you can see that the non-numeric columns are ignored if you don't pass any columns. It will only choose the numeric columns and it will actually perform sum on those numeric columns. You can see a few examples here. I have already covered a bit more advanced examples than this and hence I am moving forward. Now, if I try to use this and group the data by order item order ID to get sum of order item quantity as well as order item subtotal, you see it have returned 4 fields. The first one is nothing but key. The second one is nothing but sum of order item order ID. The third one is nothing but sum of order item quantity. The fourth one is nothing but sum of order item subtotal. However, we don't want to see this. There is no point in actually getting sum of order item order ID. It is just enough to get information related to sum of order item quantity and sum of order item subtotal. To make sure we only get sum of these 2 fields as part of sum, we should be able to pass order item quantity and order item subtotal. Then we will be getting sum of only these 2 fields. You can actually review the code here. You should be able to run it. You can also see the output. The output is as expected. However, if you wanted to round off order item subtotal sum to 2 decimals, you will not be able to use round on top of sum. You have to use with column and you have to take care of rounding. Now let's scroll down. Let's run this. Now let's review the output to understand the schema of this data frame. This data frame contains 3 fields. The names of these fields are nothing but order item order ID, sum of order item quantity, and sum of order item subtotal respectively. When it comes to the names of last 2 fields, which are actually derived fields, they are a bit cryptic. We might want to rename those fields. One of the ways to actually rename these 2 fields is by using 2df. However, when it comes to using 2df, you have to specify the call names in right order. Depending upon the names you specify as part of 2df, the names will be allocated to the data frame returned by this code. Now you should be able to run it and you should be able to preview the details of the schema. You can see that the columns are now order item already, order quantity and order revenue. Also, we might want to round off the order revenue. In this case, you can see that there are too many decimals. We will not be able to use round directly on top of sum. In case if we would like to round, then you might have to first use 2df to rename the columns. Then you might have to use with column. Now, as part of the with column, you should be able to pass the column name for the derived field as first argument, and then actual logic using which you would like to transform the data. In this case, we are trying to transform the data from too many decimals to 2 decimals for each and every order revenue that is part of the data frame written by this piece of code. Now, before running this, let's make sure that round is imported. As round is imported, now let's run this. We should be able to review the output. This time order revenue have only 2 decimals. This is how you should be able to perform grouped aggregations using direct functions on a Spark data frame. Keep in mind that you will be able to specify only one aggregate function on top of grouped data frame in this manner. You will not be able to specify multiple aggregate functions such as sum, min, max on different fields in one shot when you use this approach. For that, we have to explore agg. Let's go to the details about performing grouped aggregations using agg function on a Spark data frame. In that process, we will understand how to perform multiple aggregation operations on top of grouped data frame. As part of the previous lecture, we have gone through the details related to performing grouped aggregations using direct functions on a Spark data frame. In this lecture, let's go through the details related to performing grouped aggregations using agg on a Spark data frame. First, let's go ahead and create a data frame. In this case, I have created a data frame by name order_items. Now, let me actually run this piece of code. It will take care of creating a new object. The name of the object is nothing but order items grouped. First, let's check the type of this order items grouped. It is actually of type group data. Let me first move this properly. Now it is moved. Let me run this. You can see the type of it. It is nothing but pyspark.sql.group.grouped data. On top of it, you have a function called as agg. Also, you have direct aggregation functions such as sum, min, max, count, etc. If you want to use direct functions such as sum, it will look like this. You can only use one function. You cannot have multiple functions. However, it is throwing syntax error. I miss // here. Now it should work. You can actually see the output here. You are able to see only sum on top of grouped data frame where data frame is grouped by order item order ID. Let's say on top of sum, I would like to get min, max, etc. This approach will not work. You have to use agg function for that. Now let's look at the help on agg function. Agg accepts varying arguments. You should be able to go to the details related to EXPRs by scrolling down to parameters. You can see that when it comes to EXPRs, you should be able to pass one dict or you can actually pass a list of column objects. This is used more often compared to this because when it comes to using dict, it have its own limitations. We'll go to the examples and you will be understanding what I'm talking about here. You can also review the examples that are there as part of the documentation. When it comes to this, here we are actually passing the call name and corresponding function as a dict. In this case, we are actually passing a column object. When we use functions such as min that is there as part of pyspark.sql.functions, those functions will return column objects and hence we should be able to pass those here. However, we should be able to pass only functions such as min, max, sum, average, etc. Only aggregate functions can be leveraged as part of agg. Now let's scroll down and go to the examples. First, I'm importing sum function. Now on top of grouped data frame order items grouped, I'm using agg function. As part of agg function, I'm actually passing 2 columns. In this case, I'm saying 2 columns because when it comes to sum from pyspark.sql.functions, when we pass column into it, it will actually return column object only. So as part of this agg function, we are actually passing 2 column objects. Let's run this and let's preview the schema first. You can see the details here. It is returning 3 columns: order item order ID, order item quantity along with sum, also order item subtotal along with sum. You can also preview the data by using show. Let me replace print schema with show and run this. Now we should be able to preview the data with respect to all these 3 columns. You can see that the data is aggregated when it comes to second and third columns. Now, if you want to round, you should be able to use round directly on top of sum. That is one of the advantages of using this approach. Let's run this and then let's go to the logic here. In this case, we are saying round off sum of order item subtotal comma 2 and we are actually specifying the alias as well. Now let's run this. This time we are actually renaming the derived columns to order quantity and order revenue. You can see the names here. Also, you should be able to preview the data by running this. This time the decimals with respect to order revenue will be rounded off to 2 decimals. As part of AG, we can also pass a dict to it. When we want to pass a dict to it, then we have to pass the mappings between the column names along with the corresponding functions. In this case, this dict contains two elements. The first element's key is nothing but order item quantity. The value is nothing but sum function. The second element key is nothing but order item subtotal. The value is nothing but sum function. Even using this approach, we should be able to compute the order quantity as well as revenue. You can actually run it. You should be able to see the results. You can also use show and you should be able to get the data as well. In this case, we are only seeing the schema. If you want to review the data, you can also use show and you should be able to review the data. As we have gone through the data quite a few times, I'm not going through it once again. When it comes to this one, if you want to round off, it is not possible to round off directly. It will not work because here we are actually passing sum as strings. Unless and until you pass those as column types, you will not be able to use round on top of this. That being said, in case if you want to use this approach and get the outcome as this one, if you review this output, the column names are nothing but order item, order ID, order quantity, and order revenue. They are not sum of order item quantity and sum of order item subtotal. They are actually order quantity and order revenue. Also, if you review the data under order revenue, you can see that the revenue is rounded off to 2 decimals. We would like to achieve this using this approach. Now, this will actually create the data frame in this manner. You should be able to rename these two using 2df like this. Now the first column will be order item, order ID, then order quantity, then order revenue. So whatever is returned by this, the column names are renamed as per 2df here. Once we rename the columns, we should be able to use with column and use round on order revenue to actually get revenue using 2 decimals. We can also rename the derived column as same name, which means it will actually replace the existing column itself. This will actually create a new data frame with columns using the names order item, order ID, order quantity, and order revenue. You can run this to review the schema. You can see here. You can also run this to review the output. The output is as expected. However, there is some bug somewhere. The names are not exactly matching the order. That's why we are not seeing the results as expected. Let me actually scroll up and understand where it is going wrong. So with respect to this, we are saying order item quantity sum, order item subtotal sum. However, the subtotal is double and quantity is long. Even though this is the second element as part of the dict, the order is changed. You can see here. As part of AG, we have specified quantity first and subtotal. However, when it comes to the outcome, it is saying order item subtotal, then order item quantity. So in this case, we need to make sure this is changed to order revenue. This is changed to order quantity. Now you should be able to run it. Then you should be able to run it. First, let's review the schema here. You can see that order revenue is of type double. Order quantity is of type long. You can also review the output here. However, still it is not actually changing the data here. It is still giving wrong results. Probably I might not have ran it. Let me run it once again. Still it is not working. That means there is some bug here. I know what the bug is. In this case, I also have to change the order here. So I just have to copy this, then paste here. Now I should be able to run it. Now we can see the output. The output is as per the expectations. Even though the order of columns have changed, still the data is as per the expectations. You can review the column names. The column names are as per the expectations, and also you can see that order revenue values are actually rounded off to 2 decimals. That being said, this is how you should be able to use AG to pass dict or column objects to actually perform the aggregations. Now there are few limitations with respect to using dict to pass to AG. You can only pass one function like this on each and every column. In case if you want to get min, max, sum, etc. on one column, you will not be able to use AG. In that case, you have to use column objects only. Let me demonstrate so that you understand what I'm talking about here. Let me copy this. Let me paste here. I can delete this. I can also delete this. These are not that important. Now let's say instead of using sum on order item quantity and sum on order item subtotal, I would like to get sum on order item quantity and also min on order item quantity. Let me replace order item subtotal with order item quantity. Let me say min here. Now if you try to run it, you are seeing only one value because as part of the dict, the keys are supposed to be unique. In this case, the keys are not unique. We have repeated the key. It will only pick one of them. It will not pick both of them. In these scenarios, you should be using the column objects to pass to Agg so that it works as per the expectations. So this can be changed to this. Let me pick the code from here. I would like to use this. Now let me paste here. I miss O as part of the copy. Let me add O here. Now as part of the Agg, let me add multiple functions. The first one is nothing but sum of order item quantity alias order quantity. The second one is nothing but round off sum of order item subtotal comma 2 alias order revenue. Now let me add a couple of more functions. One is min of order item quantity. I'll be providing alias as min order quantity. I would like to add one more function on order item subtotal. Let me say comma here. Then let me say min of order item subtotal. Let me specify alias as min order item subtotal. As we are ready with the required logic, let's import min from pyspark.sql.functions. We can import by saying from pyspark.sql.functions, then import min. Now I should be able to run this. You can see that it is working as expected. We can see all the 4 columns here. This is the advantage of using Agg function, especially using column objects like this. It gives a lot more flexibility compared to other alternative approaches. When I talk about alternative approaches, I'm actually talking about both Agg functions with dict as arguments and also the direct functions on top of grouped data frame. Compared to those 2 alternatives, this approach gives us a lot more flexibility. As part of your projects, you can actually define this as standard and make sure that all the aggregate functions are implemented in this manner. But for the certification perspective, you might have to be familiar with all the 3 approaches. You need to practice enough so that any question can be answered without any gaps. That being said, make sure you are really comfortable with performing grouped aggregations using all the 3 approaches from the certification perspective. From the project's perspective, make sure you use column objects as part of Agg in the pursuit of performing aggregations grouping by a specific column or grouping by a specific set of columns.